All right, good morning and happy Monday. I'm planning on doing LeetCode contest 326 from last Saturday. Let me share my screen here. All right, here we go. Time to shine. Okay, open these guys up. Okay, so each individual digit. Okay. 9:46, oops, a.m. Okay. Let's do this. Count to 0, turn count to the end. Or, oh, number is actually just called X. Or Y and the digits of X. So let's do each character that we can transform into a digit. Hold on. Actually, let's do this. Let's do Y equals X, while Y, if Y modulus 10, X is divisible by it, right? If it's evenly divisible by it, then count. Let's do this. X modulus that equals 0. Then Y divided by equals 10. Something like that. Okay. And it should be 1, 2, and 4. That looks good. Okay. 9:48 a.m. About 2 minutes for implementation in Python 3, which is AC. Yay. Okay, nothing too fancy. View solutions. Let Y be each digit of X, then turn the count of values Y, which evenly divide X. Right, that's cool. Kotlin, JavaScript, Python 3, Rust, C++, oops. Okay, that's cool. It's always fun to start off with something that's nothing too crazy. It helps boost the confidence a little bit. I suppose we can do this recursively too, right? Let's see. Let's try this. Zero if not X, else something plus count digits. Oops. X divided by 10. Oh, wait, hold on. No, that doesn't work. How would we do a recursive function? It seems to make more sense iteratively, right? Let's just keep it a very nothing too fancy, right? X. Okay, so auto y equals x, while y count to 0. All right, nothing too fancy. Keep it super simple, right? Let's go. It'd be nice to have enough time for Q4, so don't want to nitpick and perfect. This is good enough, right? Okay, there's JavaScript, new Kotlin, and then we'll save the best for last. That'll be Rust. Uh-oh. Oh, wait, okay. So wait a minute, that didn't look right. Yeah, it's cool. Okay, save the best for last here, the Rust. Y equals X, while count to the end. Okay, and then count this equals. Okay, should be cool. Hmm. It's not quite right though, right? Just wanting to. Whatever here. Let's just do this. Right, return the count of digits of x which evenly divide x by using an auxiliary value y to consider each rightmost digit. That looks good, right? That's cool. Whatever. It doesn't have to be perfect. Okay, so we have 1 hour 19 minutes left on Q2. 1 hour 19 minutes. All right. 1 hour 19 minutes remaining in the contest. Okay. Prime factors. Okay. Partial elements is that. Okay, so what's the game plan? Supplies 1,000, and there's 10,000 of these things. Scene equals a set. That'll be the set of prime factors. We'll return the length of what's been seen. And product equals 4x in a product times equals x. Or let's just do x in range 2 until the square root of the product inclusive if the product is evenly divisible by x. Or should we just do count? Count is okay, right? Count. Four and one. Holy cow, that's not right. What's it coming back with? Holy cow. Maybe I should just hard code the prime factors then. Because that guy's not prime. Mm-hmm. or 4. Looks right. Four and 1. Okay, so that's cool. Let's see if it'll TLE or not, though. It's a quadratic solution. Oops. Uh-oh. +1 bug. It's 2. We don't ever get anywhere. All right, let's see what happens. Big money, no whammies. Oh, runtime error, integer overflow, too large to convert to float. Maybe I should sort them and do a linear scan then. +2 bugs. It's 1 bug. It's 2 bugs. Okay, so if we sort A, then we can do 2, 3, 5, 7. Set of primes. Product of them all. I guess we don't need to take the product, do we? I wonder. Big section A for each Y and P. Then, well, If it's seen, then we can break, right? Well, so case faults. Okay. Well, actually, we can just break, right? If x is evenly divisible by y, should be 411. And then this guy should not break. 25 seems reasonable. Big money, no whammies. Oh, fixed it 168. I can grab these real quick. I'm interested in the prime numbers. I don't know if I want 1,000 of them. Okay, hold on. That's 3 bugs. Plus 3 bugs. Oh, ah. Okay, well, that thing's huge. Big input. Oops. Big input. Okay, anyhow, let's go back to this guy. Let's consider sorting A. Right, and then as we go through each, we can mark what's been seen. This one is just a 4, isn't it? I'm overthinking this. Distinct prime factors of product of array. Maximum value, right? X is easily divisible by y. And all previously seen X is not even divisible by z, where z insane. Like that, maybe? 168. Okay, that looks good, but then this one's off by 1. This guy's coming up with 4, 7. It's less than 1,000. Just go to the square root of 1,000. that cool? I don't know. Let's see. Oh no, it's like way off. What the heck? Okay. I think we're getting close. Print scene. Let's just do this guy. Sorted. Smallest to greatest. 237. I'm missing the 5. The Y. That's for X. Do the same thing for Y. I think that'll do it. Okay, that's cool. Let's make sure 2 works okay. That big O one works okay. And then make sure this one works okay. Like make sure there's no regressions, right? Already have 3 bugs. What's the 4th? Yeah, it doesn't really matter too much, right? Just keep filling forward, do my best. I'm not perfect. And I'm not even trying to be perfect. I'm just trying to do my best. Okay, here we go. Big money. It's taking a bit. Maybe. Still going. Oh, output 2 is switching 1. What? Oh, okay. That's 4 bugs. Okay, 27 is no good. Something's going on with 27. Output 2, expect 1. Okay. I think it's because Y could be 1. No, Y can't be 1. Y has to be 2. Hmm. Z and scene. Oops. Let's see what happens. Stick this at the end here. Oh, okay. And we just want to test with 27. Okay, 27, what's been seen? 3 and 27. 27 divided by 3. 21 is 7, 8, 9. It's 9, right? Oops. It's 9. The original value itself. So we had 3. And how are we getting to 27? Oh, okay, let's try this. Yeah, let's throw some debug print out here. What's been seen? Okay, add 27 to scene. Add 3 to scene. Okay, so that's not right. Add 27. Is prime? If uh, I'm wondering if I need this scene thing then. Right. I mean, I just need the is prime. I'm making this like way more complicated than it needs to be. Right. I'm going to keep it super simple. Okay, 27 onto the test case list. Oops. All right, grab these guys. This is what happens when you have complicated code. It's often incorrect, right? Or when I have complicated code. It's running. It's taking a while. Holy cow, Zoli. Oh, it's printing a lot. That's why. Okay. That doesn't look right. Okay, hold on. Output limit's probably exceeded. Ooh. It should be 168, I think, or something like that. 168 looks right. This is kind of a messy solution. Oh, whatever. Let's just see what happens. Okay, actually, we don't want to print that much. Where am I printing? Oh, here it is. Okay, get rid of the prints. And yeah, who knows if I need that scene? As long as it's prime. Yeah, yeah. Well, we can fix it up here. After we get a C, how about big money, no Emmys? Okay, TL lead. Dang. Okay. Now we're forced to, okay, plus 5 bugs. Now we are TLing. In the right direction. Do we need to sort it? I don't know. I don't think so. I'm not even using that. This prime just to count. Right. I'm pretty sure the TLE occurs because of the quadratic loop here through all that's been seen. Yeah, seen is okay. Okay, maybe something like that. Looks good. Try that test case, see if it TLEs. I don't think it will. Maybe it's okay. Let's see. Big money, no whammies. It's taking a while. Not looking good. Still going. I need to get out and push. Still TLEs, man. Is that the same input that TLE done? Oh, no, it's different input. Oh, maybe it's the same. I don't know. And that's a different. Okay, so all right, well, I'll just leave that there, but whatever. Okay, so how do I improve this then? Right, I'm going through this over and over again. See if it's prime. I could use the sieve of Eratosthenes. Right? Maybe I don't know. Sieve of Eratosthenes. Right. So instead of saying every single prime, say every two, every three. Values are up to 1,000. Right. So just to see if Eratosthenes up to 1,000. Let's just do this. K equals 1000. It's not okay, then we'll continue. Otherwise, if it is okay, then every factor of x from there on, we can mark as no good. Okay, so you mark off the ones that are no good. And then you continue 2, 3. The first one's okay, right? Subsequent ones are not okay. Let's just print. Let's see. 4 I in range 2 to k inclusive. If okay, sub I and I, right? Those are the prime values. Oh, I should have list object's not callable. What am I doing here? List object, oops. Let's just do this print I for I and that. If okay, so oops, I. And let's get rid of all this stuff except for the first one. Let's do that once. All right, here's my sieve. Oh. Okay, yeah, so these are all the prime numbers to 1000 via the sieve by Eratosthenes. Okay. Just grab that thing. There's my primes. It's super simple, right? So just use my primes. Each prime. I don't think the number will get too big, right? For it's called product, right? Product for x and a, product times equals x. for x in primes if the product divided by the prime, right? Then just increment the count, right? 1, count to the end. Okay, that might do it. Let's see what happens. Okay, so that's 4, that's cool. That's the TLE one. It should come up with a solution. I'll try 2 and 27, make sure I don't have any regressions. 2, 27, TLE guy. And 68. That's strange. I thought this one was 168 as well. Okay, let's see. Oh, it didn't TLE. Okay, seems to run in a reasonable amount of time. Let's see what happens. Worst case, plus 6 bugs. All right, here we go. Oh, yay. First try. Okay, I'm pretty sure that was plus 5 bugs. I did get that one eventually. Okay, 41 minutes left in the contest, plus 5 or 6 bugs. 0 hours, 40 minutes remaining in the contest after AC, plus 5 or 6 bugs. Oops. Hey, I stuck with it and I figured it out eventually, so that's cool. Could be worse, right? Holy cow. Okay, next time do the sieve of Eratosthenes and then use that because this is pretty simple code, right? Pretty straightforward, nothing too fancy. Okay, this is a good learning experience. I want to look at how other folks solve this. Large prime optimization. Fully explained. Most of these are junk. Okay, cool. See what Eratosthenes. That's what I was thinking. They could, if your code is self-commented, you don't have to comment it yourself, right? Okay, cool. That makes sense. Find a large prime. Holy cow, that's huge. Not helpful. Holy cow, junk code. This looks decent. Okay. It's decent. Square root. Okay, nothing too fancy. They code the hard way. Complexity is not intelligent. Simplicity is intelligent. Okay. Let's see what Eratosthenes. Okay, let's do this. Here's my primes. Scene is a set. Return the length of scene. All the scene primes of X and A. something super simple like that. Each value x and a. You go through the first 1,000. If square root of y exceeds x, break. Yeah, I don't know if we need that optimization or not. Probably not. Whatever. Looks good. Okay. Hold on. Yeah, let's move on. Let's get this. I want to do this. Yeah, I don't think we need that optimization. Yeah, it's cool, right? Doesn't get much simpler than that, right? There's my primes. We'll use the C of Eratosthenes to calculate it, right? It's cool. I don't know if we want to build this thing dynamically or not. I just kind of like hard coded it, but I suppose we could build it dynamically, right? Yeah, we don't need to build it dynamically, whatever. A few solutions. Oops. So she knows use the sieve of Eratosthenes. Sieve of Eratosthenes. I need to spell that the right way. Okay, this guy's sieve. Yeah. If x is evenly divisible by y. Turn the cardinality of the scene. Right, so use the C of Eratosthenes to calculate primes. I guess prime numbers. From 2 to 1,000. Inclusive. Then for each value x to the input array A, mark prime values y as seen if x is divisible by y, and return cardinality as set of primes. That looks good. All right, try this home. So next contest, I might get less bugs. That's pretty painful. Got a whole bunch. Oh well, I stuck with it and figured it out, so that's cool. Could be worse. Could be better, could be worse. Woo! Yeah, that's cool. Whatever. Yeah, there's optimization that can be made using the square root of x, right, to limit it, but it's accepted, so whatever. Doesn't have to be perfect. I'd prefer simplicity over some solution that's maybe optimized but difficult to read. All right, let's grab our prime factors. Boom. VIP. Set of scene. Cardinality, that guy at the end here. Oops. Okay, and then scene insert Y. Okay, nothing too fancy, right? Big money, no whammies. Looks good. Yay. Okay, JavaScript. Array. Scene is a new set. That guy. P is our set of primes. Boom, this guy. Bam. X is evenly divisible by Y, then scene.add Y. All the Y prime scene. Yay. In hindsight, it's much easier than foresight to come up with these solutions, right? Yeah, use the super Tosnes, that, good to go. Okay, let's move on. I'd like to have time for Q3 and Q4. Man, how much time we have? 29 minutes. Dang, okay, let's get going. Come on, come on, come on, come on. Okay, got this guy. Our P equals int array of all these guys. Right, and let's see what size at the end here. Let's see. Scene equals mutable set of integers. Okay, that's for x and a, for y and p. If x is evenly divisible by y, add y. Okay. Big money, no whammies. Looks good. It's cool. Okay, and then Rust to be next. Vector of integers. All right, let's p equal vector of these guys. Boom. Return scene length. Use a hash set. Let mute scene equals hash set for x and a or y and p. If x is evenly divisible by y, then scene dot insert y. Borrow the y. Uh-oh. Hash set collections. Whoop. Scene, oh, okay. XI32. Uh-oh. Oh, I'm gonna borrow P. Oh, okay. Almost does not. Borrowed value doesn't live long enough. Oh, okay. That's cool. Yay. Okay, rest is cool. Nothing too fancy, right? Use the sieve Eratosthenes to calculate the prime numbers from 0 to, or from 2 to 1000 inclusive, then use, and for each value x of the input array A, mark prime values y as seen. If x is evenly divisible by y, return the cardinality of the scene set of primes, right? Yeah, it seems simple enough, right? Nothing too fancy. I like it. Okay, 25 minutes left on Q3. And let's see what happens here. 25 minutes remaining in the context for Q3. Sixteen 54, 6 and 2. Each substring has a value that's less than or equal to 60. I see. There's no good partition for this string. Case 5. I see. Okay, can we just greedily consume it? The value of the substring is less than or equal to k. I mean, greedy. Greedily consume. Left. Oh, left to right. Partitions you need. The minimum. So we want to get the biggest number that we can out of each of these things. Use I, J, and N. Count will be our minimum partition or return. this array of characters. While j plus 1 is less than or equal to n, and from integer value from I to j plus 1 non-inclusive is less than or equal to k, all right, then j plus equals 1, right? Just move j as far forward as we can. If I is equal to j, right? If j moved nowhere, then we can't consume it, return -1 immediately, right? Otherwise, increment the count and set I equal to j, which is non-inclusive. Something like that, maybe. Let's see what happens. Uh-oh. This is not defined. Oops. An array of characters. Should be 4. The other one's -1. 4, -1. Okay, let's see what happens. Big money, no Emmys. Oh, yay. Okay, cool. That was fun. All right. All right. It's all fun, right? Whether I make it or not, it's all good. It's a good time. That's cool. Okay. All right. So anyhow, 25 minutes left, 21 minutes left, right? Was it 21 minutes left? Okay. So that took about 4 minutes. That was awesome. Totally redeemed myself. Meaning in the contest. Q3. So that like took 4 minutes. Yay. No bugs, right? No bugs. Zero bugs. Nothing too fancy, right? Just greedy consumption from left to right, and that's cool. Okay, yeah, this is awesome. I'll have a little bit of time for Q4 here. Okay, a few solutions, right? Really consume the array of characters from left to right. Kotlin. All right, here we go. Solidify it here. Oops. So I can become a contestant one of these days. Contestant I would consider is like top, top maybe a couple hundred. Be super cool. To return the count conditions if possible. All right, nothing too fancy. Array of characters, k is this guy, and the count will return. Okay, it's not quite as easy to consume the characters and transform them into an integer, but yeah, we can do it fine, right? Okay, auto ij and n equals tuple, make tuple 0, 0, and I guess it's okay. It doesn't need to be an integer, right? We're not subtracting from n. While I is less than n, while j plus 1 is less than n, and string to integer of the substring a dot substr from I of length j plus 1 less than or equal to our threshold k. I like the threshold t maybe. Let's do this threshold t for consistency. It's cool, right? Threshold t. less than or equal to the input threshold t. Alrighty. That's like a t already plus j. Okay, so if I is equal to j, then we went nowhere. Otherwise, we'll increment the count and then I equals j. Right? Okay, big money, no whammies. Uh-oh. G plus 1 is less than or equal to n. Still no good. Oh no. Uh-oh. Still. Oh, it's for length, right? It's not. Okay. G plus 1 minus I. Okay, that looks right. Oh. Ooh. Holy cow. Okay. So turn to a long. Okay, so that's one of the advantages of Python for sure over C++, is it handles large numbers for us. Okay, boom. Okay, let's move on. I'd like to have enough time for Q3. That'd be awesome. Jam on that for a little bit, or in Q4, I mean. AK count. Threshold T. I is equal to j, and we failed to go anywhere. Otherwise, we will set I equal to j and then come up with count of partitions. Looks good. It's cool. Okie dokie. Let's do Kotlin. Threshold T. Count 0. We're trying to count to the end. I, j, and n. It's a triple 0, 0, and a dot size. While I is less than n. And then while j plus 1 is less than or equal to n, because j is not inclusive. And a dot substring 0. Oops, I2 plus 1 non-inclusive. Dot too long is less than or equal to our threshold t, increment j. If I is equal to j, it went nowhere, so return -1. It wasn't possible to partition. Otherwise, we'll set I equal to j and increment the count. Okay. Uh-oh. A dot length. One of those things I really hate about Java and Kotlin is that size and length are different. I really like that about C++. Everything's just size. Big money, no Emmys. Okay, cool. It's legit. Okay, and then Rust, we'll see the best for last here. Array of characters or threshold using the type vector of characters char at a equal a.chars.collect as a vector of characters. Need to count 0. We're trying to count to the end, and then ij mutable in equal 0, 0, and then the length of a, right? While I is less than n, while 2 plus 1 is less than or equal to n, and the substring from I to j non-inclusive as I64 less than or equal to t equal t as I64. Let's just do this, whatever. T as I64. J is moved forward. Oops. Okay. I is equal to j. Try -1. And the y's, we will say I equal to j and increment count by 1. Okay. Let's see what happens. Whoa. Here, okay. Rest substring to integer. Parse. Parse is okay. Let's try to parse it. Parse it to I64. Oop, dot. Oops, it should be dot like that. Oh, method not found in char. Oh, okay. I don't want it. This is more meant for streaming one character at a time, I guess. Okay, so first and for slice. Okay. Let's see the rest. Chars.count. I want to take the slice of that string, right? Oh, I gotta unwrap it. Okay. Ooh. Yay. Yeah, sometimes Rust gives me a really hard time, so it's cool to see some improvement there. It can be pretty picky sometimes, so I don't need this guy. There's our count. IJN. Okay, it's cool. And then, yeah, we don't need this, right? Okay, cool. And we have 7 minutes left for Q3. I'll post this here real quick. really consume the array, the A of characters from left to right as integer values less than or equal to the input threshold T. Like greatly consume the input array A of characters from left to right as integer values less than or equal to the input threshold T to return the count of partitions. Yeah. Whatever. Read the problem statement. Right? I mean, come on. It's pretty obvious here. The code is self-explanatory. Greedily move J as far as we can. If we can't move it, then it's impossible, right? There's our partitions. Okay, so 7 minutes left for Q3. Something tells me I'm going to probably upsolve this one. Okay, 7 minutes remaining in the contest for Q4, actually. Yeah, Q4 is the unicorn for me. Didn't write the prime numbers. Between left and right, 186. Interesting. We should be able to use the sieve of Eratosthenes, I think. The sieve of Eratosthenes. I can learn to spell this. Oops. Spell this dude's name eventually. Okay, yeah, we can use the sieve of Eratosthenes to find all the prime numbers from 1 to right, from left to right. Right would be the maximum. Let's just do this one. Let's do IJ. Okay, equals, well, let's just do it to 1,000,000, right? True times int 26 plus 1. It's going to be big. Whatever. Let's see what happens, right? Worst case of TLEs. For x in range 2 to the floor, the square root of what's this guy? This one to make it inclusive. So Marco, those is no good. The first one's cool, and all the subsequent ones are no good. For oops, let's do print I for I in range q plus 1 inclusive if okay, so I. Okie dokie. Give me a big one. Maybe it's cool, right? Let's see. Whoa. Oh no, it doesn't actually print. Okay. All right, let's do this. I term. Holy cow. Uh-oh. What is it like? About a syntax print. That's strange. It doesn't look right. What? How is that true? Y is less than or equal to k. Okay, so y equals false. What the heck is going on here? Oh, indentation. Okay. Stick this there. Oh, come on. This is junk. Floor is not defined. Hmm. Bathtub floor? Floor is not defined. Come on. Come on. Math lowercase. And let's just do this. Math.floor 10.5. From math import floor. Okay, anyhow, I imported it, so now I can do this. Okay. Okay. This guy. Whoa, come on. Give me a hard time. Okie dokie. Okay, so these are the first. How do I get unlimited scroll back? Unlimited scroll back in iTerm. iTerm, unlimited scroll back. That's what I want, right? Profiles, terminal. Let's see, profiles, terminal. I'm gonna scroll back. Okay, yeah, that's what I want. Boom. Okay, so that's my sieve of Eratosthenes to find these prime numbers. It's a big one. Okay, there's my sieve. And then smallest one between left and right. Just do a linear scan. They're sorted, so we should be able to bisect it then. Holy cow, this thing's huge. Whoa. Uh-oh. I've never seen that before. Oh, dang. Okay, this is too big. Okay, that's too difficult for our LeetCode challenge to handle. Alrighty. That's not gonna work. Okay, so let's get rid of that for now. Let's just calculate them upon demand. And then I'm pretty sure that, yeah, the contest ended, so ran out of time, but I'm gonna just keep jamming. Okay, so anyhow, up to that's I and J. Let's just do this. This guy low and this guy high. Square root of high plus 1, and then x in the range of 2. Let's build the sieve of Eratosthenes from there. Okay. For I in range, or I in if, okay, so I, okay, so those are our primes between low and high. The minimum adjacent difference. Difference is p sub I minus p sub I minus 1. That's the adjacent difference. If best exceeds the difference. Okay, we have a new best difference. Let's do this. Infinity, oops. Infinity is an integer, only 9 plus 7. Best is greater than the difference. Best is equal to the difference. I equals piece of I minus one piece of I. That first. Okay, here we go. Best if best ij diff. Okay. Those guys. Okay. Return ij if best is not equal to infinity. Otherwise, actually, I'm just going to return ij, right? Ij is initially -1, anyhow. P is not defined. I. $313? No. Closest gap between pairs 2. Let's see what candidates we consider. Diff is 2. Three and 13. What am I getting 3 from? Best is set to difference. 1 to the length of P. 9J. How the heck is this? What's going on? This should be I and this should be J. Right? What the heck? Oops, what am I? Pi minus 1. 11 and then 3. Wait, is there a different? Oh, there's a different I. Oops, okay. Call this thing K. Oops, okay. Using I and K too many times. Okay, that should be fine then, right? Okay, IJ equals. Oops. Okay, too many I's and K's and J's and blah blah blahs. 313 looks good. Or 11 and 13. Okay, -1, -1 for the other one. Okay, that looks good. Let's get rid of these debug prints. Big money, no whammies. Taking a while. Oh, wrong answer. Oops, 1 to 2 is no good. 1 is not prime. Okay. In range, the maximum of 2 in the low, right? Because we don't want to use +1 bug. Do the maximum 2 and that, then shouldn't get into that problem, I don't think. 2, 3 looks good. Big money, no whammies. Come on, come on, come on. Oh, T lead. Okay. That's a good try. Usually I don't get that far on Q3 or Q4. So, okay, game plan. Game plan. Upsolve that mystical beast. Upsolve and slay that mystical beast. Eventually. I don't know. And how can I make this faster, right? What is this? It's 300,000, 800,000. It's taking too long. The linear scan is taking too long. Yeah. I'm pretty burnt out. I spent more than an hour and a half on this. I struggled quite a bit on Q2. So we'll catch you all next time. I'll come back when I'm fresh and do the upsolve in a Q4.